morning. Buenos dias. I think that's all that I know in Spanish. Sorry. So good morning, guys. My name is Rafael dos Santos. I work as cloud architect in a consulting company called Brazilian Devs. Basically, my job is helping people get into the cloud and modernizing web applications. That's basically what I do. Today, we are going to talk about migrating legacy applications to the cloud. I'm going to share some real cases with you, especially one case in particular that's a classic ASP application that was developed 20 years ago, and it still works. And we got off on on-premises servers to the cloud, and it was kind of funny sometimes and stressful other times. But I hope you all enjoy the talk. Okay, first of all, thank you for all the sponsors of the event. Without you guys, we couldn't be here. Okay, so general advice. Okay, so let's say we work on a company, you have a software, can be on-premises or not, legacy or not, but you are going to move it to the cloud. So let's think about that. And the first advice is know the app you want to migrate. It may sound silly, but you can save time and money. And the reason I'm saying that on all my talks is when I was first hired to do this migration, and I said, okay, here is I can see the software, I have it installed on my computer, someone configured it for me. How can I make it again? How can I configure it from zero? How can I test the software to know that it's working 100%? What's the main features of the software? And the team, and every person in the team said, I don't know. I say, whoa, come on, guys. You work for this company, and how am I supposed to do a migration without knowing the software? And say, no, we don't. We are here for like 1 year. All the past developers are not here anymore, and we are still learning about the software. And you guys can wonder how much trouble was that. So we spent a lot of time just to know how the software works, like what was the pieces that was main used, pieces that were not used anymore but was there. So knowing the software will help you a lot, okay? And don't take my word as the only correct path, because what may work for me may not work for your scenario. So always test and study and try to look on all possibilities before you choose one path, okay? Keep things simple. I tried to do, like when I was beginning doing migrations, I was trying to do a lot of stuff at the same time, and that caused me troubles also. So there is one pattern that we call lift and shift. That's basically take the software as it is, the same configurations, the same machine size, rebuild it on Azure or any other cloud provider, and make it working. And then you start modernizing. We call that lift and shift. So that may be the best place to start doing migrations, especially for legacy applications, okay? And avoid unnecessary optimizations at first. There are some things that we can do, for sure, for modernizing. Like one thing that that's common on the jobs that I do, it's most of the external third-party software that they use are installed on the server, but nowadays we have the DLLs on NuGet. So basically, one of the optimizations that I do is add reference to the NuGet package instead of using it installed, because it helps a lot and reduce some trouble. But let's get started. Okay. First, and one of the most difficult things to choose, data center location. Okay, on Azure, that's the current. I took this yesterday from the Azure website. That's the current map of all Azure locations around the globe. Okay, so there are 54 regions and 140 countries that you can work. That's kind of a lot, and that was my mistake number one. Because what we did was, they used Hackspace. I don't know if you know the company. They are kind of common. The software was hosted on Hackspace. And since we are doing tests first, what we decided was let's restore the whole system on Azure and keep using the same database on Hackspace. Because if something bad happens, we can still use the old servers. So what we did was looking at the map, their data center was in the Central West, the part central of the United States, and say, okay, let's look to the closest one to that location, and let's build the software there. Major mistake. The data center didn't have all the features that we need. The network in the data center was poor, like it was very, very slow. And it wasn't the fastest data center, it wasn't the closest location for internet communication. So in order to help you guys choose that, I put some websites here. There are two in particular that you guys need to look. That's called, the first one is Azure Speed Test, and the second one is kind of V2 of the same website. So I put a picture here for sample. I took that yesterday from the hotel. Brazil South is the closest one. I don't know if it's clear enough, but it's in the medium, it's 86 milliseconds. And the second one closest is the East-West. So for us in South America, Brazil South will be the closest one, always, in the whole South America. But it's not the cheapest one. Like American ones are cheaper than Brazil South. Yeah, I know it's crazy, especially for us in Brazil, since tax and a lot of government stuff. Sometimes using the East-West data center is cheaper than host in Brazil. So you need to measure price and speed and features, okay? The third website, it's the Azure Status one. So before we start to doing the actual migrations, and was one of the mistakes that I did in the past also was, hey, okay, this is a data center that I want to start to building. And after I start to create things, I saw, okay, this feature that I need is not available in this data center. I need to move to another one. So before you start creating stuff and deploying to Azure or any other cloud provider, make sure that all the features that you want are available in the data center. I put in here, I will publish the slides after. There is a site called Azure Status that will help you guys see. For example, the first picture is not clear, but virtual machines and VNets are available in all data centers in America. Sorry guys, I'm in front of you. But for example, this one, the second one, is about the Azure App Services. And containers and app services are available in all America. But Azure Signal WAR, for example, that's the latest one, is not available in Brazil. So even that you host everything in Brazil, if you are planning to use Azure Signal WAR, you need to use in another data center. Okay, so it's good to plan ahead. Okay, so that's kind of the, after we pick the data center, most of the legacy applications, nowadays we have microservices, Docker containers, and Docker Compose, Kubernetes, and a lot of stuff, and it kind of makes our lives complicated and difficult. But when we speak about legacy applications, they have like a common architecture, a common design, that's the three-tier. And normally it's one or several databases, but like you have the database tier, you have the web or app server tier, and you have load balancers that you need to scale your application. And that's what I'm going to focus today. Okay? So, first of all, how many of you guys know Azure? I'm talking here, but I forgot to ask. Okay. Who is mainly a developer here? Well, who works more with infrastructure? Okay. So we have this kind of dev and IT war. So you have like developers want to spin up and use everything and open ports and build the infrastructure by themselves. And infrastructure people know, you can't do that, I can't open that port. Let's make everything closed inside the VNet and not let anyone else outside enter in our infrastructure. Say, oh, I want to open port 1333, that's the SQL Server port, because I want everybody to the external world to access it if they have the username and password. And the infrastructure will say, no, you can't do that. Give me your IP. Oh, here is the VPN credentials. You need to go to the VPN. And that's funny sometimes, but not always. So as a developer, that's mainly what I like to do. I like PaaS, platform as a service, because I don't need to worry about like load balancers, scale up, scale downs, and VNets and all that stuff. I just need my code to run, and that's because I like more. But the first point is, it's not always an affinity choice. I can't always choose PaaS because I like it more. Maybe the team is more comfortable with infrastructure, with creating virtual machines, with creating VNets and managing firewalls and all that stuff. So if you are doing consulting, you need to work on your team skills, or even that you are an employer, you need to think on the whole team, because like you can go on a vacation, you can get sick, you can go outside, and other people in the team need to be comfortable also with like managing what you are doing. So keep that in mind. So another thing that's kind of set the pace on the migration is like custom components. This application that I'm talking, it has some custom com plus components. So I couldn't use PaaS because I need to register it in the machine level, and like that is at least Azure App Services doesn't allow you to do that. You can't change these things on Windows or on the host. Okay, and there's another things like PCI compliance. Also, if you work with credit cards and financial industries, you need to take care of that, and it's not always simple. So you need to take that in mind also. So just to make a comparison for those that are not familiar with, PaaS, that stands for Platform as a Service. It's simpler to use, okay? You don't need to like worry about updates, load balancers, size, and all that. You just give the software, here is my code, run it for me. I don't care about any of that stuff as long as my code runs. And as a developer, it's most what I like to use. IaaS, that stands for Infrastructure as a Service. It's like you have way more control over the configuration. You need to spend more time in the beginning, but you have automations and scripts that make your life easier. It's not as like too much time consuming, but you need to spend more time to configure. But once it's done, you can just take care. So keep that in mind also. As a sample, we are going to talk about Azure virtual machines. Okay? Is it good up to here? Like I'm speaking too fast? Are you guys understanding? Okay, thank you. So on the PaaS side, I'm going to talk about app services and app services environment. That's the most common choices on Azure for working with PaaS. Okay? So for app services, you can pretty much run every language and every web framework. Like any language, pick. Like Node.js, .NET, .NET Core, Python, Ruby, like Go, anything, and any framework, okay? And it's very, very easily to deploy either manually or using a CI/CD tool, an Azure DevOps. You have pre-built templates that you can just like 3-4 clicks, and you can get your code auto-deploy into Azure. It's pretty simple. Nowadays, you can run on Windows, either your code or using Windows containers. It's not good yet. The container takes like almost 30 minutes to spin up, since it's the minimum size that you can get is 2 gigabytes. So it's kind of huge container to spin up. Microsoft is working to reduce that. But on the other side, you can use Linux with pre-built images for Node, PHP, Python, and Ruby, if I'm not wrong. Or you can just bring up your container and run. So you can run pretty much everything, and it's easier. Another cool feature that I like on Azure App Services are slots that you can, within the same app service plan, okay, so you are already paying for that plan, you can create copies of your app without paying nothing extra for that. So you can have 2, 3, up to 5 copies of your app running on the same server, and that's the best way that you can deploy new code, do some smoke tests before deploying to production. You can either use something like Traffic Manager that I'm going to talk tomorrow about to split the cross between the versions and see if everything is okay before you move everything to production. It's a very, very cool feature. You also have application insights that was native on Windows, but it works native. It's not native, but it works flawlessly on containers now, even on .NET Core or Node.js. Even the live traffic that you can see, like real traffic coming to your servers and the requests and all the cool stuff that wasn't available on containers are available now. So for those that are familiar with Sentry or other monitoring tools, Application Insights does the same, and it's amazing. Okay? So, and you can have on-premises integration. It's not, so small parenthesis here. We not always migrate 100% to Azure. Maybe we migrate little stuff, or we need to migrate the web services, but we still need to access on-premises components like databases or other servers. So in order to do that, App Services also provides on-premises integration, okay? With VPN gateway, VNet, it's in preview now. You can deploy directly to a VNet in Azure that was available only on the private instances, or outbound IPs. Outbound IPs is the easiest way. You can have, once you create your app services, you have the whole range of IPs that are used for external access, and you can get that range and put in your firewall, and it just works, okay? There is a very expensive version of the app services. You have the free, shared, basic, standard, and premium. Premium it's quite expensive, but worth the money. And above premium, you have app services environment. That's mainly when you need PCI compliance. So if you work with banks or you do credit card transactions, unfortunately, you need to use app services environment. But despite being expensive, there are a large set of cool features. And it goes directly to your VNet on Azure. And the instances are just yours instance, like no one else's code. It's not shared. It's just the VM. It's reserved just for you. And it's the only way that you can use internal or external load balancer, okay? So even that you create like a premium one and you are trying to protect you from external access, the addresses should be public, even that you use like IP restrictions or username and password authorization. The load balancer should be public. If you want just an internal load balancer, app services environment is the only way that you can do that, okay? So let's stop about PaaS once, and let's talk about IaaS, okay? So virtual machines, they are easy, I would say. They are, as a developer, to be honest, I don't like to configure them too much. There are endless flavors and sizes. I'm used to say that they can be good or bad. It depends on how it works, because you have like, if you go to our Windows Server VM, you have like 2008, 2016, 2019 preview. You have data center R2, and when you go to the size of the machine, you have like D, B, DV2, DV3, DVS3, and F, Gs, Hs, and have all this kind of size that specifics for one purpose. In general, you guys want to use the DS V3. That's the best ones for general and web applications. Okay. You have support for custom images also. You can bring your own premises machine. You can run a sysprep on your server, take the image, the VHG file, the VHGX, and move to Azure and create machines from that. It's mostly what I like to do when I'm doing migrations. Create the base machine with everything that I need. I run sysprep, leave the file in the blob storage, and I create all the files, all the machines that I need from that file. So it's the easiest way, I guess. You can use Azure Automation. You have automation accounts to run everything that you need with PowerShell or Bash or any other script language that you like. You can also you can install custom script extensions on the machines. So from your terminal and using Azure CLI or PowerShell, you can run scripts or commands in all the machines that you control and that you like. It's something very useful also. Okay. Virtual machines, for those that like to control more your infrastructure, there are some cool features. You have like one VNet, so when you deploy a machine, you need to deploy to a virtual network, okay? And you can have one network security group, the NSG, per machine, or you can share NSGs across multiple machines. It's also good for when you want to control external traffic, sorry, on multiple machines. For example, for my databases, I use one network security group. For all my web servers, I use one network security group. For all the other machines that I need inside my network, I can either pick one specific network security group, or I can use another one, okay? Another cool feature on Azure now, it's recent, like 4 or 5 months ago, you have managed disks. Previously, like until last year, you need to take care and manage your disks. You need to store and take care, take backups and all that stuff. You don't need to do that anymore. You can just use managed disks, so you have backups, replications, and all that stuff that it's really, really good and helpful for Azure. Also, you have some pre-built images that are for SAP, for those that work with SAP. Also for SQL Server, that has, the price of the machine is different. So you pay the Windows and the SQL Server licensing on the same price. So if you don't have a SQL Server license, you can just spin up a SQL Server virtual machine, and the price will have the license include. That's for production, okay? If you are doing development, please don't do that. Spin up a regular virtual machine and install the developer version, because otherwise you can spend too much money, okay? We use, I think it's one with 16 cores and 64 gigabytes of memory. It's almost $4,000 a month. I made that mistake when we was doing development, all that stuff, and I say, hey, we are spending $4,000 a month for nothing, because we don't need a lot of the enterprise features that we don't need. So let's create a new one, install SQL Developer, and do all the development within that special machine. So 4,000 savings per month. Okay. That's for virtual machines. We have something that Azure calls virtual machines scale sets. It really depends on how you are familiar with Azure to use that. So virtual machines scale sets are a way to manage a large group of machines. Okay, it can be just one, but it can be 1,000 machines using a single endpoint. So everything that you do to one machine, Azure replicates to everything. So you can either use what I was saying, to use like Azure Automation, custom script extensions, and create your own script to do that. but you need to apply on each machine, or you can use scale set. So scale sets is what I like to use for web servers. So I manage all the web servers at once, okay, before switching to Kubernetes, but that's for legacy, okay? So it makes it very, very easy to manage multiple virtual machines, okay? You can deploy it with both load balancer or application gateway. I will explain what those means in a bit. And updates are something that need to be very careful. By default, it's automatic, okay? So once that you apply a change to a machine, once you update the software or you change the configuration, it automatically changes all the machines in the scale set, okay? I kind of recommend you to put that into batch at least. Don't leave in automatic, you can have trouble. Because if you do something bad with one of the machines, you can lose the whole scale set. It's kind of hard to restore. But you have batch, so you decide how many machines gets updated at the same time. Or manual, that you decide each machine at its own time. Funny story about that. Since we do credit card transactions, we need to disable TLS support on our machines. One of the guys changed the scripts to run a PowerShell script and disable TLS 1.0 at the machine level when the machine starts. But it also disabled what was necessary for remote desktops. So we lost connectivity to all the machines in the scale set, and we had to recreate everything from scratch because it wasn't automatic. So we lost all the 5 services at the same time. So be careful. Okay? So I covered basically what is required for web applications. Okay? So for databases, the choice it's almost the same. You have the pass against IS. Okay? It's the same rules that I talked so far. Okay? So in general, virtual machines are easy, way easier to migrate to virtual databases. Because you can just run the same version and with the same configurations, you can bring your license and it's easy, especially for those that work with SQL Server. Like, the application is still running on SQL Server 2018, 2028. So we couldn't use Azure SQL database because we need to do a lot of changes that wasn't possible. And it was not safe to migrate to 2014 or 2016 since nobody in the company knows the software 100% that it could run tests. So VMs in general for databases work better since you can hide in the VNet, protect from external access, and bring the same configuration, okay? But on the other hand, like if you don't use too much custom configurations, the PaaS versions are easier to scale and offer some built-in features. For example, to illustrate the difference, you can just create one database server and run your software, but it's not safe because if something bad goes to the virtual machine and you don't have a disaster recovery plan, you can get too much trouble. This database that I migrated was almost 1 terabyte of data. The backup takes almost 2 hours to restore. So we couldn't run just one VM. We need to have replication configured. So configure a SQL Server replication with hand, like from scratch, it's very hard. At least I'm not a DBA, so for me it's hard. If you are a DBA, it's easier for you, sorry. But you have also templates for that on Azure, but even with templates, it's hard to do that. You need to have like Active Directory configured, federations, 2 machines on the same data center or 2 machines in different data centers, and can get in trouble. If you are using Azure SQL database or the managed instance, you can just go to the portal and enable replication to another region, and your database will be ready for use. Spoiler alert for those that will go into attend to my talk tomorrow. I will teach you guys that, how to do replication and survive to failures, okay? So on Azure, we have some options, okay? We have SQL VM, SQL Server into the virtual machine, or pretty much any database, Postgres, MySQL, name it, Mongo. You can just create a VM or use a pre-configured virtual machine and spin up your container, okay? Also, that's for IaaS. On the PaaS side, we have Azure SQL Database. That's one of the best servers that Azure has. We have Postgres managed now that works very, very well also. We have MySQL database, okay? We have now in public preview, if I'm not wrong, or I don't know if it's in GA or public preview, the managed instance, okay? For those that work with SQL Server and use like jobs, send emails from the database, and use a lot of SQL Server features, managed instance is the best thing that you can have, because it's the best of both worlds. It's like it runs on a VM, it's a SQL Server installation just for you, but it's managed by Azure. So everything, replication, backups, access, scale up, scale down, it's managed by Azure team, and you can use a script or portal for that, and makes your life very easy. You don't need to worry about taking backups or storing the backups in another region and things like that. Managed instance does all of that, and it's cheaper than run SQL Server on a VM. Kind of Azure is pushing everybody to move to there. Okay, and if you are from the NoSQL world and use Mongo, you can use Cosmos DB with the Mongo connector. You don't need to do any change on your software, despite changing the connection string. It just works. Okay. So last but not least, I talked about the web servers. I talked about databases, and now we're going to talk about traffic distribution, okay? Because you need to spread your traffic across multiple machines, otherwise you can't scale, you can't handle traffic, okay? So on Azure, we have a couple options to do that. Traffic Manager, Application Gateway, okay? Load Balancer, and Azure Front Door, that's a server that it's in preview. What I can say so far about front door, that it works, it's better, like will be better than application gateway on my own opinion, okay? But it combines load balancer and application gateway on one single service. It's worth start looking, but I don't recommend you to use in production yet. It's very, very preview. There's a lot of features missing, and some of basic stuff that you try gets error without no reason. So be careful, okay? Traffic Manager, okay? It works at the DNS level. It routes the traffic. It doesn't load balancer the traffic. It's important that you keep that in mind, okay? It works at just mainly at the DNS level. It's when someone tries to access like myapi.trafficmanager.net, you just tell, hey, here is one IP or one CNAME that you can use. It's just for that. It's not for load balancer, okay? But when we talk about cloud architecture, sorry, it's the first thing on the top of our load balancers, you are going to use Traffic Manager. I'm going to explain more about that in my talk tomorrow, okay? But it routes incoming traffic for better performance and or availability. You have 4 types of configuration. You can use like ordered servers, like priority 1, priority 2. You can distribute between waves, so 50-50%, 60-40, 70-30, 80-20, 90-10, or anything like that. You can spread your traffic across multiple services, okay? It increases your app's responsiveness, especially when you need to run an application globally in multiple countries, okay? And you can also combine traffic between your on-premises servers and your Azure or any other external services, okay? So if you are doing step-by-step migration, you can distribute your traffic using Traffic Manager. Okay. You have also Application Gateway. Application Gateway is a load balancer, but it only works at the HTTP level. You can only distribute traffic on ports 80 and 443, HTTP and HTTPS. It's only for HTTP, okay? But you have cookie affinity for cross-session sharing. For legacy applications, most of the applications use sessions and cache a lot. And once you do a login on the server, you need to use that server until you log out. So cookie affinity is for that. Load balance also supports, okay? Supports any Azure or on-premises or other cloud providers endpoint. You can use Application Gateway even that your web servers are not on Azure, okay? It's just for distribute traffic. You can also use SSL offload. All your DNS and your SSL certificates can be on Application Gateway, and you will validate the certificates, and your virtual machines or your servers don't need to have that, and you can use port 80 to do the request inside your network. That it's a performance gain. It's not that much gain, but it's a performance gain, and I recommend you to do that because manage certificates across multiple virtual machines, it's complicated, even using Azure Vaults for that, okay? It comes with a web application firewall. It has a firewall integrated that has all the OWASP, Open Web Application Security Protocols, v2 and 3, if I'm not wrong. You can choose that and protect your application. But one major downside on Application Gateway, and front to worry at, is that it doesn't support wildcard domains. So let's say I own contoso.com. I can't bind star.contoso.com. For that owns SaaS application and allows your customers to pick a custom subdomain on your own domain. You can't use Application Gateway because it has a maximum of 20 bindings. So even that you can script and automate the creation of the endpoints for your customers. If you have more than 20 customers, you can't use, and if you have like 100 customers, it gets impossible to manage that. So you need to use another solution. That's the major downside, in my opinion. Okay. About load balancers, it's the easiest way to scale up applications. You put a load balancer, you get an IP, you redirect your website to that IP, and you can distribute traffic across your websites and virtual machines. Okay, it's very easy. You can use for load external traffic from the internet, or you can use inside your virtual network. Okay, it has native IPv6 support also. Application Gateway doesn't. But the major downside is that it only integrates with Azure endpoints. So if you are using an Azure load balancer, you can only integrate with Azure virtual machines and cloud services. Okay? Tips and tools, we are almost in the end. Okay? AZ copy, it's one of the tools that you want to have on your machine. Okay? It's how you can upload and download large files. So my 1 terabyte database, even compressed backups get almost 300 megabytes, the compressed backup. And upload that to a blob storage, you can't just go to the portal and upload the file. You fail. So with AZCop, it splits the file in chunks and upload chunk by chunk and gets very, very fastest. Okay? Another tool that's very, very handful is PSPing. Okay, you can't ping between machines on Azure or from your machine to Azure directly. The ports are blocked for security reason. So if you want to test the responsiveness between your machines, you can use PSPing. It's how I found that the North Central US data center has the poorest network across all the data centers. A single PS ping on the SQL Server port took almost 1 second. So it's a very useful tool. General devices after you migrate your application. Okay, so you migrate, it's everything up and running, so you need to start to think on improvements. So for those that are not familiar with cloud applications, general devices and things that you can do very easily. Move static files to a blob storage, okay? For speed and responsiveness, you don't want to requests to show your web servers be competing with static file requests. So once you move all static files, CSS, JavaScript, images, to a blob storage and redirect the traffic to there, you have more bandwidth on your web services and your application will be fast, trust me. Add a CDN in front of your blob storage or web server. Like if you can't move to a blob storage easily, at least add a CDN instead of serving the files directly from your server. Because you can distribute your files globally. Once you enable the CDN on Azure, or any other CDN, your files get cached around all the globe. So if I'm accessing your website from Brazil, I'm going to get served files from the Brazil data center, from the Brazil edge. So the files will be closest to me, so it will be downloaded fast. And you don't need to use blob storage for that. You can just point the servers to the same public folder on your website, okay? And also acts as a cache layer. Most of web developers nowadays tend to ignore cache headers. So they just forget to configure that, and your files doesn't get cached, and you get extra requests on your server without having to. So CDN makes it very easy to do that. So Redis cache, especially if you do cache in session, if you use like ASP.NET Web Forms and use session and use cache on the server, you have a Redis session state provider. You can just repoint your configuration to use Redis, and you can spread your traffic across multiple servers. Okay? And last but not least, queues, since you can move things to background process. So let's say, for example, when you do a user registration and you need to save in the database and send the welcome email, the welcome email doesn't need to be sent right away. You can move it to a queue and send that from a background job. You can make your application more scalable and more fast, since the HTTP request will be small. Okay? Muchas gracias. Thank you.